And let's talk more about Skale Network. Can you explain, please, how is it different from the bunch of other existing layer 2 solutions?
So basically, there are two camps now. In the layer 2 world, there are two camps. One camp thinks that the future of the world is many blockchains. But these blockchains will be Ethereum-compatible, right? But many, and we do see many blockchains, not so many now, but we have Scale, we have Matic, we have POA network, we have Silo, we have Avalanche, right? So there are quite a number of some other guys. This Luxo, a really great network that one of the great programmers, Fabian, from ETH, created this network. So there's quite a number of people now that think that the future is many blockchains, and there are a number of people that think that the future is Ethereum mainnet and some kind of helper solutions, but not blockchains, more like single computers that do transactions and submit them to blockchain. And then these single guys, they get somehow policed and monitored, something which is called rollups and plasma and everything. So basically there are 2 points of view: Ethereum mainnet and many single computers that help it, or Internet of Blockchains. And there's a huge discussion. And as you imagine, people in both camps, use all kinds of arguments. But the truth is that at the moment, the R camp, I would call it R camp, the camp of blockchains is winning. If you look at what's running, most of layer 2 solutions that actually run now and have users, they do something that people call app chains. We call them application specific chains. Some people call them side chains, but in reality just blockchains, right? Like many blockchains. And rollups, in my view, not doing so well, but I am biased because I am in this camp. So Scale belongs to the camp that blockchains are better. There are several reasons why. One of the reasons is that if you run something on a single computer, you are very much subject to something which is called front running and MEV. You probably have heard these like hot terms. Actually very simple. Front running means that if you want to buy a ticket to your favorite like music band, and you go to the ticket office and you want to buy a ticket for your favorite show, whatever, you get to the ticket office and you see there are no tickets, but there's a guy who is actually like standing by this ticket office and offering this ticket to you twice more expensive. So the guy actually front run you. You were running to the ticket office. The guy actually got there first, bought a ticket, and now there's no tickets anymore. And the guy is reselling the ticket to you. So front running is like, has been existing much before computer science. It's just the idea, if I know you want. Yeah, that's the front running. And then maybe actually it's very simple. The best people that can do front running are miners, because miners are assembling the blocks. So the miner can easily put a transaction in front of yours, front you. So miner extractable value, it's miners making money from information. You're sending a transaction, they insert something in front, they're exploiting you. So you go to Uniswap, you want to exchange money, right? And what you end up seeing that you want to buy some token, you send a transaction, I want to buy this token. When it actually gets bought, you see that the price is higher. Why? Because the guy actually bought this token before you and resold. That's happening on Uniswap all the time. People making like hundreds of millions of dollars, not just maybe billions now per year, just from this very simple technique of front running. So that's front running. And MEV means that miners either do front running, many of them just do it, or they just have some other guys and they make money, take money from those guys, and the guys do front running. So this is huge MEV. And so on MEV on rollups gets much worse, because on rollups there's literally a single computer that does a rollup. So if you are a rollup operator, you get all the transactions, and you just can do so much of this front running and MEV. So rollups have this problem that MEV and front running becomes really, really bad. On blockchains, front running, especially for proof of stake, is not so easy because you don't know in advance if your block wins. So you don't know in advance if you can front run or not, because block proposing can be random. So that makes front running much harder. In addition, there are much more complex mathematical algorithms that you can use on proof of stake chains that can use encryption to totally remove front running. And actually, one of the talks that I had on ETHCC was about this interesting mathematical algorithms that you can insert into blockchain, into proof of stake blockchain, that actually totally remove front running. And the idea is actually pretty simple. The transaction is like when you send your transaction, let's say you want to buy a ticket to your favorite band, you encrypt this letter. So when the letter is going to the ticket office, it's encrypted, no one can read it, they don't know what you want to buy. So they can't front run you because what you want to buy is encrypted. So it's encrypted, and then it goes into the blockchain, and at the very end, the entire blockchain collectively decrypts it using very cool mathematical algorithms. But for these algorithms to work, there has to be a collective, not just a single computer, but many computers decrypted, but only at the last moment. So basically, to make long story short, on proof of stake blockchains, there are mathematical algorithms that prevent front running. And on rollups, the problem of front running is actually getting really, really important. So that's our critique. That's why we think that long-term blockchains, op chains, application chains, or side chains, whatever you call it, will win. Some guys say no, rollups will win. And I think this will get somewhat resolved by the end of the year. But my prediction is probably the truth will be somewhere in the middle. It's probably some people will use rollups and some people will use side chains or application-specific chains. And if the blockchain industry grows, probably there will be enough space both for blockchain guys and for rollup guys.
Yeah, so you have with whom to compete, and as well there are big players as Ethereum, but Ethereum is quite slow, and you claim that you achieve much faster transactions and as well secure. So can you explain how do you achieve such fast transactions without sacrifice of the security?
Yeah, that's a great question. So there are several reasons why Ethereum is slow. Definitely one of the reasons is because it's proof of work chain. So you do actually lots of number crunching for every block, and number crunching actually takes time. Currently on Ethereum, I think the average block time is around 15 seconds, maybe 13 seconds. And so one of the reasons is number crunching. Another reason is that the propagation of blocks in the Ethereum network is quite slow. One of the reasons why it's so slow is the Ethereum mainnet was made to be very democratic. So you could just use any computer basically to join Ethereum mainnet. But because the network ends up being like not like enterprise level network, not so fast, blocks are actually propagating slowly. So because of all of these reasons, it's slow. In our case, we don't have proof of work, and we were able to use algorithms that Ethereum didn't use for various reasons, but most of the reasons because of proof of work. But the fact is that in academia, in research at universities, there were algorithms that designed, starting from 1982, long time ago. They were studying some algorithms of something they called consensus. They didn't even know about blockchain, just were trying to solve a problem, how people vote when they are in different places. Like, let's say you have a parliament, and people in the parliament vote for constitution. Usually it's very simple, right? They raise hands and say for constitution, if it's 2/3, a particular amendment wins, and you have a change in the constitution. So voting when people are all in the same room is really simple, and that's something which is called consensus. Consensus is basically when people vote and agree on something, right? Turns out that if people are placed in different places, let's say you have all of the senators in the parliament, right? And each of them sits in her own apartment and has a mobile phone. I can only call a single other senator. It turns out that reaching consensus in this case and voting is much harder because bad guys can start lying. So I'm calling you and saying, I'm voting for this. And I'm calling other guy and I say, I vote for that. So I create essentially havoc, like chaos in the system by lying and saying different things to these different people. So because of this possibility of lying and inserting malicious information, turns out that if you have malicious guys, what can happen is that it's really hard to vote. And what can end up happening is that some people will think there was this decision made, and some other people think another decision was made. And for blockchain, the decision is what's the block, right? There are different people proposing blocks. You need to decide which block wins, which block proposal. So this mathematical problem of voting when people are located in different places, it was studied since 1982. And initially, there was the first algorithm that people designed, was designed in 1983. And this was really complex and working really slowly. So pretty much like for almost 30 years, mathematicians and computer scientists were improving these algorithms. And through a series of improvements, actually the entire field of science was born where people were improving algorithms. And now in 2015, there was an algorithm designed at University of Nantes in France by a really great guy. And this algorithm actually works very fast. So there was like a series of improvements. And when we kind of started to look at the blockchain, we started to think how we can connect science, that things that are happening in academia, to what people were essentially coding. Because many people, when they did blockchain, they didn't really know mathematics. They were just trying to code it. And many blockchains got just like coded in the sense that there was no mathematical background. But we tried to first understand what's the science behind it. And when we first split the problem into pieces and looked at what was available in computer science, we realized that for every piece, we can choose an algorithm from computer science that actually works pretty fast. And we actually didn't design anything. None of algorithms that we run were designed by us. But we were able just to actually pick and choose and create a system out of many, many different mathematical things. It actually works pretty fast. And because of that, because our consensus work, the voting part, this voting part works really fast, we were able to have a really, really fast finalization time. So in our case, the finalization time is around, on our current network, is around 4 seconds. And our competitors have finalization time maybe 200 to 300 seconds. Finalization time is different from block time. If you have a blockchain, you have a block. The bad thing can happen, this block can be reverted. It's like a time machine that it can revert things. So if you send me money and I receive like $10 and I see it like on Etherscan, I can't really think I have the money because 10 seconds later, the time machine can go back and the block can disappear. So because of the block time doesn't really matter. Some people say, oh, I have this. There are many of our competitors, I won't name them, but some of our competitors say, yeah, we have like 2-second block time. And if you look at it, and then you need to wait for 100 blocks for them to finalize, for transaction to be final and non-revertible. So the actual finalization time is 200 seconds. So that's something not everyone understands. But what actually matters for blockchain is finalization time. In our case, is very fast. Actually, probably we can't make it faster. I think it as fast as we could make it. But then the good thing about our thing, because at every step we have mathematical things, we can actually prove that our blockchain is provable from the beginning to the end mathematically. If less than 1/3 of our guys are bad, our blockchain works well. And now what we are planning to do at Skale is to write down all of our blockchain and submit it as a paper to one of computer science journals. So we'll publish and make for everyone available all of our algorithms, how they work, and people will see we have nothing to hide. You know, our project, one of the things that is good about us, we are totally open source, and we have literally nothing to hide. Every single thing which runs on Skale Network is actually open, available on GitHub. Some other people, you know, you ask them how it runs, they don't tell you. And then you look at their GitHub and this part is not there. So for many projects, people are like, how this thing runs, right? Like, what are the security assumptions? Who controls this particular key? How is my money like secure? And not all blockchains tell you this information. In many cases, it's like a little secret. And in some cases, it leads to security breaches. Turns out there's a guy with a single key and the guy controls like a bridge. And then the keys get stolen, or maybe the guy like goes to like islands, makes like plastic surgery, takes all of the money. So there have been like several situations where, you know, there was like this secret thing, and then it got
decentralized
broken.
exchanges mostly.
Yeah, it happens all the time. And making everything decentralized takes lots of coding and lots of mathematics. So sometimes people like, okay, I have to do this. How do I transfer money from this thing to that thing? Okay, let's put the guy like with a key, and the guy will be like controlling the money transfers. And you won't believe how many chains have these guys, literally like, you know, people, humans, like controlling the transfers with the keys. And then usually people try not to like advertise this. So you go to their website, you don't know how they're doing this bridge, right? You go to GitHub, there's no bridge. So it's like a secret component, but the secret component turns to be like a human. So the human either like loses the key. There were like several cases recently where people like had this key and they weren't even smart enough, like, you know, this like ledger, the hardware wallet. People weren't even smart enough to put it on a hardware wallet when it's more secure. They would just put the key into like MetaMask on their like laptop. And then they go to like whatever, play some game as a virus, and the virus like just takes the key from MetaMask, and then billions of dollars, or at least like millions of dollars of crypto get stolen. And the funny thing is that happens, you probably know, like every week you have news like this, but usually even users don't care so much. We're actually getting used to this breaches happening. But in our case, we're trying to actually make it secure. So in our case, there's no like single guy or human like controlling things. We're always trying, if something is happening, there will be many computers, so it's decentralized. And to break the system, you need to break 2/3 of these computers. Definitely, every system is breakable. There's no absolute security. Any blockchain can be compromised. You know, there could be tomorrow, there could be a virus that wipes out the entire Ethereum network. It's possible, you know, in a second. It's always possible to break things. But the question is, you know, people at least need to know from the beginning what are the security assumptions, you know, how the system is designed. So if you put your money into a system, at least you need to understand how can you lose this money. And in many cases, people don't. So they just believe on other people. And then when it gets lost, people are like, oh, I lost my money. So it's a big part now of crypto. I think it's getting better. You know, if you compare like what's happening like 5 years ago, where like this crypto exchanges, the centralized exchanges you mentioned, right? Like there was just like a single key, and then they will pull the rug, or they would lose the key, and then all of this money. It's getting better. Actually, we do have some centralized exchanges that are pretty secure. I think Coinbase is pretty secure nowadays. And Binance, probably not so easy to hack Binance now, but some of the smaller ones, I think, you know, especially in the past, they were really easy to hack.
Yeah, and can you share as well some upcoming plans for Skale Network?
Yeah, that's a great question, Anna. So, like, if you do a startup, I think usually like there's this lean startup model where you release like MVP of your product, minimum viable product, and then in the best situation, the lean startup theory tells you that you only need to do what people ask you to do. So our network is already pretty complex. So I think our plans for the future, for the next like 6 months, the most important plan is literally just polish it and not change anything, just make it much more stable. Because currently you have so many things you could do. You could do a website. You could take like Airbnb or Uber and put it on Scale and run it on Scale. So we have actually a pretty good set of features. You can take any website, any centralized application and run it on Scale. So for the most part, actually, we'll just try to like polish things. But there is one feature which is so great that we're actually working really hard on it, which is, I just explained this feature to you, this threshold encryption that allows you to prevent front running and MEV. So once we release it, if you take Uniswap and run it on Scale, you will be able to take Uniswap and run it on Scale, and without modifying any single line of code, it will be all behind scenes. It will magically have zero front running and zero MEV.
So will we see the version 4 of Uniswap on Scale?
Yeah, I think definitely we will see that that's all of the DeFi applications. So every DeFi application, you could take literally like source code of DeFi application, and it will magically have protections against MEV and front running. So we're super like hot about this, and we have people like working around the clock implementing this threshold encryption. And I think it's weeks before we have the first version of it, at least in beta. So we are working really hard on that one. So threshold encryption is big, and also long term, people want to be able to run more real-life programs on Ethereum, because Solidity is kind of a new language, but people have lots of like real-time, like real-world like websites, right? Like if you have a website like Airbnb and you want to run it on Ethereum, Airbnb is not probably written in Solidity; it's written in Python. So we've been having so many requests to be able to extend. People say, okay, here's my chain, but I have Python code. How do I run Python? And Python is a great language now because you can do so many things on it. You can do machine learning, you can do websites, and it's really easy to use and learn. So we are long-term really interested in running Python in Ethereum, inside Ethereum. So it's like becoming like Ethereum plus, in the sense that we're adding things. We're still having all of the old things, but we're adding new things. So another big thing for us is this Python. And then if we have Python, people will be able to extend it. And long term, the idea would be that we being extensible. So if you have Linux, you can run Linux, but there are some packages and you can install a package to do this, that. So creating a platform where you will be able to, you want to change Scale and you want to create a new package, and then you will be able to easily add it to Scale. And us will be more like working on the core. For instance, to give you an example, Linus Torvalds on Linux, right? He was always like working on core of Linux. He never did anything else. He didn't care about like how, like whether it's like what the color is or what the buttons are. He was always concentrated on the core, and people were like creating these packages, and all of the community creating Linux as a collection of many independent pieces. That's actually the model that we would like to have, if possible. Us just keep on creating the core, and then letting people mix and match and create those pieces, and then being able to extend. Because as a small team, we need to say, Steve Jobs said that it's more important to say the features where you say, no, I won't implement the feature. It's very important to actually not try to do too many things. So that's our kind of strategy, to keep on polishing the core and then creating a community. And creating a community is also, it's a hard thing, but we are trying to reinvent the conferences a little. So there will be something which will be like Scale Conference, but we won't call it Scale Conference. It will be more like we're thinking more like a Burning Man idea of self-expression. So it's not like a pyramid where people at the top say something and people at the bottom just like sitting at the conference, like flipping their phones, because no one is like listening to talks anymore. People are just sitting like flipping their phones. So we don't try to destroy this thing because it's really ineffective, and create something more like a camp or a
Yeah,
place
I
where-
saw the announcement of on your
Yeah.
Twitter that you're
So there
looking
will
for
be-
developers.
yeah, so we actually, yeah, so we even our own project, we had an event in Mexico where we got together in a secluded place, like in the nature. It has to be really secluded so people can't go anywhere, so we have to interact. So we had our own team, and it was really great experience. People just getting to a remote village in Mexico and just they had nowhere to go pretty much. So they had to interact and become friends. So that was number one. The second thing will be a Skale camp. We call it a Skale pre-Y Combinator camp, where people will stay there for 4 days, interact, and then submit ideas to Y Combinator. So these are startups that want to run on scale. So there will be Skale engineers, there will be the startup guys, and there will be some of the venture capitalists that we know. So there will be the Skale camp. The current plan is to have it somewhere in the mountains, probably in Utah, in the States, in October. And then there will be something which we don't even have a name for. One of the ideas called Skale Collab. It's a collaboration. It's not a conference, but it's going to be a replacement for conference, where again, there will be no talks, or maybe very like small talks, very short, but lots of discussions and interactions and self-expression. So that's gonna be the last thing. So we get basically the big thing for us is now to create a community, and also create a community which is modern and not just like what other people do. So that's our great plans. Actually, we're really excited. And if anyone is watching this video, if you want to join Skale, you want to help us, collaborate with us, you want to run something on Skale, please go to our Discord. The Discord is like the place to interact with our team, and let's talk.
Yeah, that's a great mission to build the right community.
Yeah,
Thank you for such interesting and informative conversation.
Thank you so much. And actually, I really appreciate talking to you. It was really nice meeting you at the THCC, and I wish you lots of success. And in the future, I'm always happy to talk to you, about anything, blockchain.
Thank you. See you at other conferences.